Transportation is changing rapidly as people consider convenience, cost-effectiveness, their carbon footprint, and safety. This new era of mobility, with automation, electrification, and connectivity, requires a new type of talent to drive innovation forward. Welcome. I'm Ayanna Howard, Dean of Engineering at The Ohio State University, and this is Enginuity. Since 1988, the U.S. Department of Energy has organized collegiate automotive engineering competitions to provide a challenging, real-world training ground for the industry's future workforce and to accelerate the development and demonstration of technologies. Sponsored by General Motors and MathWorks, the EcoCAR Challenge puts engineering students at the cutting edge of automotive engineering, exposing them to industry standard tech and resources. Teams are provided hardware, software, and a brand new vehicle to be used in each competition. Ohio State has competed for 32 years in these challenges, and we're very proud of the winning tradition our students have built. The team is currently competing in the EcoCAR Mobility Challenge. When this episode airs, our students will be in Arizona for this competition's final year, and we're very excited to have two team members here with us now. Team Project Manager Colin is a second-year graduate student. He just completed a master's in industrial engineering after earning his undergraduate degree here at Ohio State. Shaumya, team lead for connected and automated vehicle systems, is also a second-year graduate student, working towards a master's in electrical and computer science. She completed her undergraduate degree at Cummins College of Engineering for Women in Pune, India. Welcome to you both.
Thank you. Excited to be here.
Yeah, I'm delighted.
I'm really excited to chat with you as the EcoCAR team is such a highly visible example of the experiential learning opportunities available to engineering students here at Ohio State. I referenced the success of Ohio State's EcoCAR Challenge teams over the years, but Colin, I'm going to give you the opportunity to brag just a little bit.
We're really proud of the tradition that we've built over the past, like you said, 32 years. And it's been a winning program. So over the past 13 years, 12 of the past 13 years, we've finished in the top three. And actually 7 of the past 8 years, we've actually earned first place in the competitions.
I think this is amazing and really speaks highly of students, past and present. Shaumya, let's talk about the current team members and the skills they bring.
So right now we have multiple sub-teams in our EcoCAR team, and we are members of 8 team leads, and there are around 20 to 30 undergrad students, and the team leads are grad students. So it is over the past 4 years, we have been a huge, big team, which helps the EcoCAR grow.
What's interesting is you mentioned 8 sub-teams, 20 to 30 undergrads per each. And my big question is, multiple disciplines, or are they all, industrial systems and electrical computer scientists?
EcoCAR consists of every discipline. If you're from an engineering background, you can come in and work as a EcoCAR member. And majorly it's mechanical, and then there is electrical, there is computer science, there is industrial. So it's multidisciplinary.
Basically, if you have an interest in this, all are welcome.
Yeah. It's a learning process. You don't need to have a background of it. So you learn as you go through.
Part of this challenge is that teams get a brand new vehicle. I would love to have a brand new vehicle just given to me so that I can explore and experience and figure it out. And so, Colin, give me some insights on, what kind of vehicle, what was done.
As we mentioned earlier, this is a 4-year competition. And at the beginning of year 2 is when we actually received our car from General Motors. So for this iteration, we're working on a 2019 Chevy Blazer. It's a midsize SUV. And from there, we basically tear it apart, just a bunch of students going at it. And the whole purpose is to re-engineer it. Year 1 was all about planning the architecture of the vehicle and doing our research. And then year 2 is actually implementing everything that we found. However, as we all know, year 2 fell in that 2019-2020 school year. So about halfway through the school year, we experienced a full halt on development. And coming into year 3, so fall of 2020, that's when development really began. So essentially, over the past 2 years is when we rebuilt this vehicle. So the goals of this project were to turn the naturally aspirated Chevy Blazer into a hybrid electric vehicle. So with an internal combustion engine in the front, electric motor in the rear, a massive battery pack in the trunk, to improve the fuel economy while maintaining the performance of the vehicle. And with that, we also wanted to implement some connected and autonomous functionality. So as the automotive industry moves to autonomous vehicles, many vehicles on the road today have these technologies as like stepping stones. So a major goal for this iteration was having student developed autonomous functionality. And those are the biggest goals: improving fuel economy, maintaining performance, and looking to the future to improve safety with these autonomous features.
You mentioned testing, building, refining. What I want to ask, and actually, Shaumya, you can answer this. What does a typical day or even a typical week look like for a team member? And what are students learning through their participation in EcoCAR?
My typical day would be learning new things. Like since the day I joined until yesterday, I have been learning every single day. And as a CAVS team member, my major part, or I would say for every sub team in EcoCAR, the major part in this final year is testing and tuning. So we know for the past 3 years, we know that our system works and it works in the best case scenarios, but in year 4, we need to make sure it works in the worst case scenarios as well. Like, I would give an example. Like right now, Ohio has a very cool temperature. So our car system works pretty fine. And the components work all right. But when we are shipping it in Arizona, we need to make sure that it works as good as here, because the temperatures are going to be very high. We need to test the limits of our components. So this is the major role in year 4. Like every sub teams need to make sure what are the limits of their components.
This is year 4 of the EcoCAR Mobility Challenge, which means it's the final year. How have you navigated the pandemic and kept your eyes on the prize?
Yeah, so it's definitely been a major challenge for this iteration of the competitions. The pandemic really hit the beginning of like the second year. And so that's when we saw a basically shutdown of all development. And so coming into year 3, so starting in fall of 2020, really most of our vehicle development was over the past 2 years. Even though it's a 4-year competition, the past 2 years has been pretty jam-packed with everything from vehicle integration, so our mechanical and electrical teams actually like constructing the vehicle, making sure everything works properly and is safe. And then from there, we move on to our controls team, really making sure that all of those different components can like communicate and cooperate with our like Shaumya's team, the CAVS team, connecting to automated vehicle systems. Then testing to see, so those automated systems that we're putting into the car, are they refined? Are they robust? So all of that, a majority of it was in the past 2 years.
If you think about these students, and this is more for future prospects, how would a student even get involved?
We have like fall and spring involvement fairs where we try to engage as many students as possible from undergrads, grads. We have our website u.osu.edu/EcoCAR, through which they can join in our mailing list and get to know the meetings that we have. We have a lot of fairs. We have a lot of involvements that we keep doing every month. So there are undergrad meetings twice a week. So they can join in and come in through our team members or through advisors.
You have your team, you have undergrads, you have grad students. And so let's fast forward a little bit. When this episode is posted next week, you too will be in Arizona with your team for the final leg of this competition. So Colin, can you walk me through what the team will be doing out there and even how the winner is determined, given that, top 3, we've been final 1 on a couple of occasions?
We're spending about 2 weeks in Arizona. The first week is going to be in Yuma. So General Motors has their desert proving grounds in Yuma, and that's where all of the dynamic events for the car will take place. So that's where the car that we built is actually going to go up against the other schools in the competition to test things such as energy consumption, acceleration, braking, or the autonomous capabilities. Anything that really has to do with driving the car and how it performs is going to be in that first week. The second week, we're going to transition to Phoenix. And that's going to be more the business side of things, where we have each sub-team giving a presentation on the development process they followed, what they were able to accomplish, and really just kind of put the bow on the whole project and present it to industry partners and different competition sponsors.
Okay, so 2 cities. You talked about kind of the activities. And so, Shaumya, what is the actual criteria? So you're showing the judges things, you're going through, like, what is it that they're looking for?
So the first part, the main motive of EcoCAR Mobility Challenge is first fuel economy and other is connectivity. The competition has given us like a list of requirements that you need to accomplish to get like full points, half points, 70% or 50%. So on that basis, we are judged. We have like different on-road events where we test different parts of the whole EcoCAR challenge. Like for example, CAVS has an event called perception test, and there is an event called connectivity mobility test where we try to communicate with the between the car and the intersection or the lights, traffic lights. So we have been given like a list of requirements that we need to fulfill, upon which we get points, and they're like 12 universities. Who gets the highest points wins the EcoCAR challenge.
You mentioned things that resonate with me. You mentioned perception tests, you mentioned mobility tests. Now, you're the team lead for connected and automated vehicle systems, correct?
Yep, yeah.
So, as a roboticist, I like these things in terms of data and figuring out things. So I'm really intrigued by the use of artificial intelligence in vehicles. And I know from experience that this is probably a unique opportunity for students to get, in this case, real-world experience with this technology. So what does exposure to these concepts and systems as a student mean to, we'll say for industry or talent development for General Motors and the rest of the automotive industry?
Previously, I've been working on a lot of machine learning projects and AI projects, and they have been, the only difference is they have been limited to working on a laptop. I run models, I run algorithms, try to tune it, find accuracies, do a predictive analysis, and that's limited to my laptop. But when I got into EcoCAR, I need to understand how I can actually integrate that with a vehicle which has a different controller all in itself. Like there's a controller called micro autobox, which is actually the brain of the car. So I need to make sure that all the inputs I given is actually complying with the inputs of the micro autobox. So how to communicate with different components of the car is very important, which is what I learned. And I have been talking to a few employees from the industry, and when I discussed about the technologies we use in the student project, it is very much similar to the technologies they use out in real-world scenarios. So they were pretty shocked and surprised that as a student, you have been working on these and you are a fresher. So that's the kind of experience EcoCAR has given me, and I'm delighted to be a part of it.
Basically, as you're learning machine learning, algorithms, and AI, it really is this embedded aspect on hardware.
Yeah. I'm from an electrical and computer science background, so I have no idea about how mechanical aspects of the car work. So this is something new to me, and this is something I'm learning, and the embedded aspect is what is required in the real world.
This is perception, machine learning, AI, all these nice things. But if I think about the next series, this is the last year of this one, there is a next series called the EcoCAR EV Challenge, which actually kicks off in the fall. And so Ohio State has some really exciting news. I'll let Colin explain.
After participating in these competitions for 32 years, we were kind of looking at what else could we do? How could we grow our program? And EcoCAR has given us a really great platform to build from. So actually for the EV Challenge, we're going to be partnering with Wilberforce University. It's a historically Black university in the greater Dayton area. And they are working to develop their engineering program. And we are able to bring them into what we've developed in this competition, the team that we've developed over the years, partner with them. And with that, they get the support from the competition organizers. And together we can work on a collaborative project and really create something special for the next iteration.
So true collaboration.
True collaboration.
Beautiful. So these types of experiential education opportunities at Ohio State are plentiful. And this is just one exciting example. Competitions like this can breed advances in technology and prepare students for exciting careers. I'm so happy that Colin and Shaumya joined us before they fly out to Arizona for 2 weeks. We wish them and their teammates the best of luck as they wrap up their competition. Go Buckeyes!
Go Bucks.
Go Buckeyes.
If you like what you heard and are interested in learning more, or suggesting your own topics for Enginuity, be sure to connect with us on Twitter or Facebook at OSU Engineering. Thanks for listening.